Hi, and welcome to my project presentation for my Development 200 Term 1 assignment. My name is Wolf Burta, my student number is 211000255. I was the developer for this assignment, and just a fun fact about me, Wolf is my first name, and it's an abbreviated version of a very common German name, Wolfgang, and technically you pronounce Wolf actually as Wolf, but people pronounce it differently, and I don't mind either way. So the project that I created is called Fruits, and it's an interactive chart-based website, and it provides a whole bunch of fun information about nutrition and price trends over 10 years about various different fruits. So apart from just the fun facts that I have on the home page about the fruits, there's also two other pages. First, a comparative view where you can compare two different fruits and you can see their nutritional info compared in engaging visuals. And secondly, you can also look at the historical prices of these fruits in Europe specifically over a period of a decade. And it's a great tool for people that enjoy fruit, for health enthusiasts, and even nutritionists. The technology that I've used specifically is React, which is great for modular and reusable and maintainable code. And it's also a great fast user experience that uses a virtual DOM. So not everything is refreshed the whole time, just the components that need to. Bootstrap was also great, that uses pre-built responsive design components. It just makes development much faster and simpler. Chart.js was a must because we had to create visually appealing chart components, and it just works really well with React, and it's also great because it's lightweight. Tailwind was another UI library that allows for much better control, much more in-depth stylization, but it's also very flexible, and it works great alongside Bootstrap. Axios was used for HTTP requests, and this was to fetch the data, in other words, from my two APIs that I selected. And finally, React Router was for routing between the different pages, so it creates a single page experience. And what was the purpose for this website? Well, I wanted to create something fun and informative about nutritional information that's available to the public. And it's not only great because it increases awareness of different fruits and why we need them, but it promotes a healthier lifestyle and eating habits for us. And the goals that were met included, it's an educational tool that's now available with this nutritional info and price trends. Use technology to provide a fun and engaging user experience, and there's a multi-page application now that's accessible and simple to use. So in the brief that were provided, we needed to create these three different pages after selecting the appropriate APIs and doing a whole bunch of research and planning. And on the landing page, we have that breakdown of information and just a contextualization, what the website is about and what to expect and how to read the data. The comparison page, where you can compare those two fruits with three different chart elements, and the timeline page, where a line graph was needed with 5+ properties, mine is anyway more, but different fruits where you can see the trends over time. And it's a component-based user interface with all of the React Router navigation, Axios technologies being used, and then just overall unified visual aesthetic that has already been applied on this public GitHub repository. So I'm going to talk about functionality. We're starting off with the edamame API. This is the first API that I selected, and it's on the comparison page. And you basically get nutritional insights about the fruit, whatever you have compared. You can see here this white section in the middle. This is what one of the responses would look like. There is basically an array of objects, and you can't see the array, but this is just a small section. And for one of them, this would be an example of 100 grams of apple. You can see there's a calcium section with the quantity being 10.92 milligrams of calcium being in an apple. And this was then taken to create the graphs and dynamically populate them. And essentially what would happen is when you change that drop down to a different fruit, the data would update, and subsequently the graphs would have to update. So when you select, for example, on the right, there's the lemon and the apple. If you change, for example, just the lemon side graphs would have to update, but also the bottom one, because the bottom bar graphs actually uses information from both. So although the apple one still remains the same, if the lemon one is changed to a different fruit, that would just have to regenerate again. The next API that was selected was the EU Agri-Commissions API. This is for the pricing, and you can see the response on the right. It's a bit intense at first, but when you break it down, it makes a lot of sense. Each of these objects are basically like an entry point that someone added to track the price at a specific current time in a specific country of a specific unit, a specific variant of a fruit, and a variety. So it's very in-depth, but really, really great API. And you can see, for example, in Portugal, in that between the 16th of March and 22nd of March, it cost £50 for 100 kilograms of Lanette oranges. So really, really great. And that was utilized then for the timeline price chart. So whenever a fruit type was selected again from the dropdown, that API would be called for that specific fruit, and that data would be consolidated and filtered and would be read through to the chart that would visually chart the line. But some solutions and challenges. This challenge that I faced, the biggest challenge that was faced was the data integration. Because it's the two different APIs, the information that they return is quite different, but the chart.js system is quite similar. They need the same data in like the same kind of format, and that was quite tricky to manage at first. But once I implemented custom backend functions and methods so that the data that's returned is just standardized and it's easy to use, it became a lot simpler, the developing process, and especially just having that API documentation for both of the APIs nearby really helped a lot. And the next challenge was responsive design. Just because there's so many visual elements and so many structured and complex things, although it's simple, it's also difficult to make sure it's responsive and still visually visible and accessible on different screen sizes. But this was very useful. Not only did Chart.js come with its own responsive elements, but Bootstrap and Tailwind CSS really helped a lot in making it faster and efficient and just having a lot of control over creating responsivity. So I'm going to explain two parts of code. We're going to start with just component-based implementation, which is very key of React, the language, or the library rather. The fruit type card was one of the components that I created, and I reused it several times, but specifically on the homepage, you can see I used it a lot. And this is for each of the different fruits. And you can see it's the same component being used over and over again, but we just pass in a unique fruit property. So apple, kiwi, lemon, orange. And that property being passed through is then passed also through to its subcomponents. So this is inside that fruit type card. And the image basically gets that fruit property and then also the description. And the title even is passed as it is. It's not really passed, it's just used directly. So that will then continue more deeper, and there's a switch case inside of both the image and the description subcomponents, and the switch basically checks what is passed through. If it's apple, that is the description we want, and then that paragraph and the image source will change respectively. Now, how do we populate the line chart? The charts work basically the same. I'm going to focus on the line one because it's more simple to understand. But I used the EU Agri-Data as previously mentioned. The great thing about that API is it doesn't require authentication, so I don't need to register and create user information and stuff. So it was simple to an extent, apart from having coarse errors, because it's a long story, but essentially that was also a challenge that had to be solved. But using Axios to get the specific URL. That URL was customized with parameters. Basically, I wanted the response JSON file that this API would return to me to be consolidated and also more relevant. I don't want apples, mangoes, and pears to be in the information. I mean, there's a lot of information. I want it to be much more specific with like apples only. I want it to be in Europe as general, not a specific country. I wanted Europe as a whole. I selected the month of 6, in other words June, for my standardization, and then all of the different years from 2013 to 2023. So I wanted 10 different entries because my line chart requires 10 different data points. That is then taken, this information that I get, and I'm filtering it with my service custom service functions. So the one filters it only to one per year, and the other one to a single fruit variety or variant. And then on the timeline page, this is where that chart is on. Whenever the drop-down changes, this use effect React hook is triggered. As you can see, the selected fruit state. And what this will do is, first of all, it will set the loading state. So there's a loading screen that will display, and then it will get that fruit prices. That is the function that I just showed you. And it will store it in a fruit price state. And this state data will then be passed through to the chart component, the line chart itself on the page. And then again, we're moving inside the chart line component. And then another use effect is here. And this will also be triggered whenever data changes, whether it's the fact that it's changing from an apple to a lemon, like a different fruit, or if it's changing from not having data to having the first data on page reload. And then we take this data that we have gotten now some of that fruit information, but it's not clean yet. It's not just numbers. For the chart, we need only numbers. So we'll take the numerical points to populate it on the line, and that will essentially create a graph for us visually. So now let's take a look at a step-by-step walkthrough of the website, and we'll look at the features and functions. So this is the landing page or home page, whatever you'd like to call it, where it explains the information and data and the different fruits, explores more about each of them. So up here we have a navigation bar. You can also see I have a custom cursor that I've implemented. We have this landing page, then a comparison page, and then a timeline page. Up here is a header with some imagery. I just want to showcase, first of all, that this website is responsive and it does change as you resize it. I'd like to keep it this size. I feel like this is just a comfortable viewing width, but you can see down here we have a section where we explain all of the different fruit types and why each of these fruits are beneficial for your health. This is the fruits that will be showcased, their data on the other pages. And down here I do explain as well all of the different data points, and we have a donut chart that showcases the protein, carbs, and fat, as well as the calories. We have a polar area which showcases the different vitamin daily concentrations, like the recommended intake. We have composition of sugar, water, and fiber. And then on the timeline page, there is that timeline of 10 years where it tracks the prices of these different fruits in Europe in euros. And down here, we also have some more navigational links to go to the different pages, as well as some of the social media pages. All of these work as well. So let's explore first by going to the comparison page. As you can see, we're introduced, there's a little loading screen, and then we are shown all of these different graphs. So here we have melons versus peaches. We're going to compare the nutrients for each of these fruits per 100 grams. So it's similar. Both of these are the exact same weight nutritionally compared. So here you can see both of these fruits in general, are mainly carbohydrates. You can hover over it and see 8.16 grams of carbs in melons and 9.54 grams in peaches. You also have a bit of protein and fat as well. Then we have the vitamin daily percentage. There's vitamin A, B6, C, E, and K. It's a bit skewed and difficult sometimes to see because they really do differ so greatly. But you can click on these and also hide them, and then you can showcase and see better. 6% daily intake for vitamin B6 when you do intake 100 grams of watermelon. Then we have the sugar, water, and fiber intake, and this is a direct comparison between each of these fruits. Again, when you hover over it, it does give you the exact sugar in 100 grams of peach, which is 8.39 if you want to see that. But this simple interface just gives you a good overview. But then you can also decide to change and compare different fruits by simply clicking on these drop downs and selecting a different fruit. So if we want to compare apples with, let's say, lemons, it changes accordingly. You can also see it changes the fruit imagery, the background colors change, as well as the chart colors. So then let's go on to the timeline page. page, which is the final page. This one tracks the price per 100 kilograms in euros in Europe over a 10-year period. So you can see here for peaches in 2013 was really expensive at 160 euros. When you hover over each of these points, you can see again the detailed information of each. And it only goes up to 2023 because we haven't finished 2024 yet. Again, there's this drop down where you can decide to select a different chart. And as we wait for the information being collected, you can see there's a little preloader. But yes, that is that. You can also now navigate back with these navigational links. Thank you very much for watching.